I'm going to use the material from the project that I directed on the old Beas and speak a bit about potential responses to this recently published paper, which does not pay any attention particularly to historical matters. In addition, in that paper there are incorrect interpretations, and some of their interpretations of their own data go too far, and I'm not going to talk about that, but you will be able to read this paper yourself if you would like. So I prepared this since I've been here, and I didn't ask any of these collaborators to be part of this paper, but I wanted you to know that this is not my own work entirely. All of these people were part of the team that I directed, except for Sanjay Gupta, who's a geologist and has also been doing some really interesting and I would say good work on climate change, and he was able to discuss with me some of the issues that concerned me. Okay, so in this context, what I wanted to, the way I thought I could put it here is that we've done a lot of work on Indus centers. In fact, when you say Indus civilization, people think of 5 centers, or if they don't know about Rajagawa, they think about 4. And there's been a lot of really good work, over the past 20, 30 years. The chronologies have been refined. I would say that that was a big contribution of the Harappa project. I don't think that that chronology should be used everywhere, but it works well there and can be called upon. The architectural histories that Michael has done within Mohenjo-Daro have been extremely important, because the way in which it was presented originally, we all know, was absent pretty much of well thought out chronologies, put it like that. Also, I didn't list here, but I think the work at Mohenjo-Daro that the Italian team did was extremely useful, because in a way, it helped to think about how we might look at rural settlements in a much more interesting way than had been done previously. There's been interpretations of organization. There isn't a consensus, but people have ideas based on archaeological evidence. And I like, in particular, a lot of the work that's been done on craft production and other aspects of infrastructure helps us to understand what ordinary people were actually doing at the big cities. So I just marked some of the large cities on this map. And then, so what I want to say is there's been much less research on rural communities and ecology. When you talk about cities, you forget all about the ecology. And one of the points I'd like to make is that though I'm not a cultural ecologist, one of the things we know now is that there's a tremendous variety in the ecologies in which our cities were located, and that has to be considered when we think about what was happening. This map shows some early looks at rural communities. The first one down at the bottom, no, I'm sorry, the Cholestone survey outlined for us the large number of archaeological sites on the Hapra. At Mohenjo-Daro, Louis Flam did not look at settlements specifically, but he looked very closely with a team of geologists at the river systems. And Greg Russell moved down into Gujarat, into an area that had not been extensively examined, especially from the point of view of identifying rural sites. But it was also an area that he identified as very different ecologically. And then up at the top is the project that I directed, and my interest in it was that we had a good chronology at Harappa, good diagnostic indicators of particular time periods. It would work perfectly looking at settlements for which we didn't have permission, obviously, to excavate, so we're basing then all of our discussions on settlements and picking up objects. diagnostic materials. And then these others are other kinds of projects that look in rural areas, outside of cities. The ones in blue, more work that's been done in Gujarat. Then we'll see what happens at RWTH, but the ASI has done a huge number of surveys. They have not necessarily connected them to any specific site, which I think is an advantage. You saw the numbers a few moments ago. And now Cameron Petrie is working at Kalibangan, essentially doing a survey. So this is the map that Greg Purcell produced. He really, he examined the area and identified a large number of sites. He then excavated at Abercat, Orient Timbo, and at Rochdy. From that work, he seems to have spread his ideas beyond Zoroaster. And I think this idea of, his idea of domains came out of it. Greg came to this work as essentially a trained ecologist. He had worked with Robert Adams, and I think those were the eyes he had in looking at this research. This map essentially identifies somewhat different ecological zones. Now, I think this is a great map, and I think it's a map we can go back to if we want to think about the cultural ecological diversity. But I'm not so happy with this map, where these sort of ecologies morphed into political loci, because we don't actually have the archaeological data to prove any of this, that there were separate domains, and to, in a way, move off of the topic of, is there any center within this civilization? That's a big question. And I happen to have this with me to show that this is from pulling together some of the data from Ariana and looking at the distribution of settlements by time. And what you can see is in the lower groups, I had to divide them by the southern plain, the western plain, and the north and the eastern plain, because this is one way that we can see how there was a shift and an increase in settlement. We can talk about whether or not that represents population movement or something else, and I'd like to propose the something else a little while. So this is the dry bed of the Bayaz River, where many sites were discovered. They were discovered, most of them, by the Punjab Archaeological Survey, which is a project that Rafiq Mughal initiated. He, after having been in Cholistan, recognized the importance of rescuing sites that were still extant before there were developments. And in that context, they found about 1,400 sites. But we just had permission to look along the Bayaz to convene our project around it. And also, our only interest was in the Harappan-related settlements. This map you've probably already seen, and we published it a couple of times. The numbers simply are references to the archaeological sites that we found. We have been able to break them up into different time periods. So there are 3 that actually have what look like Hakra materials. There are many others, about 14 that are early Harappan. All of these are mature Harappan, and then there's a fall off when there are only 3 or 4 that are late Harappan. So there is some sort of shift in settlement. They are located on either side of the river. Now this is nice. This is what Carl calls dots on a map. And of course, we wanted to go beyond dots on a map. So part of my team was a geoarchaeologist, and then I later incorporated the data that Steve Weber was collecting at Harappa. We don't have any plant remains, obviously, because we didn't do any digging. We do have some phytoliths, and they pretty much complement the archaeobotanical material from Harappa. The archaeobotanical material at Harappa also is time sensitive, uses the chronology that we have there. Well, I've been only talking about Harappa, and that is my plan. And that is because when we conceived of this project, we had a couple of questions about distributions. One of them was that there had been a lot of publications about climate change. Some of them were the major ones that covered huge areas. Others were studies that were done where phytoliths were and cores were collected from lakes. And one of our problems was that if you put them all together, they're very contradictory. One says it's cold, dry, other said it got wet. And we realized that the only way to resolve this was to go to all of the areas that were of interest and look at data locally. And that's something about this project that I think is important. We also, because we didn't want to put just dots on the map, Mauricio wanted to find out what the farmers were actually doing. And based on our research, we found that they were quite smart. When they went to Harappa, they picked the highest ground. They didn't just land there, they picked the highest ground. And then we can't very well at Harappa put together where their agricultural fields were, because we didn't have permission to do that. And this could be done. But this is just an example from one of the sites that we identified. This is a place called Chakrabani, and nearby is La Tiba. We used soil maps that showed the landforms, and all of you who know about the doabs, these places of high ground. So these are the places where the archaeological sites were located. They were near them, on the edges of them, and this would mean that obviously they wouldn't be flooded over. We looked at existing levees to see whether we could project how far out, how much land they would have to do their farming. And we also used some geological methods. We went to, this is one mound that happens to be two mounds. We aren't sure whether it's two mounds because the people in the village decided to build a road, or whether it always was two mounds. And, well, I don't know what happens to that. Okay. This way. Okay, so we wanted to know two things. Why did people come here? And why did they come when they came? They've been at Nergar for quite a long time. People have been coming from that region over to the Roaring Hills. So it has some sense of something interesting here with a river. So we wanted to know why they waited so long. And the answer that we came up with for this location, just based on looking at different categories of soils, was that it wasn't really until, so here are some early dates, going all the way down here to 13,000. So people were not there because the whole terrain was very unstable. Up until here, around 6,900, you start to get increasing stability. And then it's here that we actually found cultural levels, and we have a few dates from here. We actually have many other dates, but this is just from this location. So my point here is that by using these cores, we didn't use huge cores, we had no permission for that. We used hand cores that took us down to 3 meters, and we were able to bring in buckets of sediment that were the basis on which we did this. We did other things. We did not want to just do what often archaeologists do when they do settlement studies. They walk around and pick up the diagnostics, and as a consequence, you get these very uniform chronologies. You find your mature Harappan, your late Harappan, etc., and you don't find anything that deviates from it. So we broke our sites into 5 by 5 meter units. We used a systematic sampling, a random sampling strategy. We weighed and counted all of the items within each of the units we selected to sample, and then we left them all there, and then we removed the diagnostic materials which have been, which are now being drawn. What you're looking at here is using GIS. We first put all of our data in an Access database that speaks to GIS, and we then could show the different areas of densities of materials. So, for example, if we, God willing, we were ever able to go to this site again, and we were interested in the early Harappan, we'd probably go to this mound and this mound, but we wouldn't go with this one for a start if we wanted the early Harappan. You can see that in the mature Harappan, there are much higher densities, and it covers the entire mound. And then this is what happens in late Harappan. Now, we weren't especially happy to find that we had what looked like some evidence for some sort of a big change. And I asked Rita Wright, who's a climatologist, to model the precipitation. This is a little bit of a controversial modeling. Archaeologists don't like these things, but climatologists don't feel that uncomfortable. And what this shows is that, obviously, we had, in this model, the reduction of precipitation, the annual precipitation, and then I don't think I brought it. And then we also were able to show that there was a reduction in the discharge in the river in the bayous. We also had other evidence. This is very limited, and we're still trying to get this information. We used stable isotope analysis and the C4, the limited number of days that we had. Here, this is an error. These demonstrate that it's a dry and warmer period, so we have some corroborating evidence beyond Rita Wright's model. Somehow, yeah. Okay, so what I think I've demonstrated there is that looking on the local level made a lot of sense. That by looking on the local level, we were able to satisfy ourselves that from an archaeological perspective, we could say one way or the other that something happened at a particular time period. Now, this is the map that was generated by a paper that was published in Proceedings of the National Academy of Sciences, which is supposed to be the best thing since sliced bread. They wrote a paper called Fluvial Landscapes of the Harappan Civilization. Originally, it was called The Fate of the Harappan Civilization. The claim they make is that from using high-resolution imagery and some collection of quarry, that they were able to demonstrate that the end of the civilization came about with a reduction of the monsoon and some major reconfigurations that they made of the river system in the Conquer. The numbers that you're looking at there are the places where they did their transects. They went to places closest to the Himalayas and did their quarrying. I think you can't see it better there. So, for example, where's that one? So that's a set of quarrying that they did. Here's a transect that they made. And from that, they modeled the situation in which what we had previously understood about the impact of rivers from the Himalayas was incorrect.
This 1 to 3 is on the other side of Rorwegen, huh?
Yeah. It's all closer to the Himalayas because what they're trying to show is that this reduction happens right from the top, and they can't get it all the way down, although they do a little bit of that. So this is the map, another map that they produced, and one of the other complaints of a number of people about this project is no archaeologist would accept such a broad claim with the number of dates they have. And here are just some that represent what might interest us. Well, here we don't particularly have anything. But there are other charts that they have that show these days, but I would say they're not as good as, they're less, they represent what they're trying to say less than these. And then here's just another thing that shows these changes. So, climate-controlled landscape transformation, is the quote, caused the Gopher aqua system to become ephemeral. Only monsoonal-fed rivers were active during the Holocene. As the monsoon weakened, monsoonal rivers gradually dried and became seasonal. This increase in hydroclimatic stress, increased vulnerability, settlement downsizing, diversification of crops, increase in moisture monsoon regions, etc. And there's the reference. Okay. No. So, what happens when you look at the archaeological evidence in the face of a statement like that? And so what we have for evidence is the research that Steve Weber did at Harappa, the archaeobotanical research. Now don't forget, the only thing that's going to affect this farming system is the monsoons. But in fact, the Harappan farming system was based on summer and winter cropping. The winter westerlies through this region, especially in the upper Punjab. Again, I'm tempted to talk in the large macroscopic way that they talk, but I'm just talking about the Bayas. This is the situation there, summer-winter cropping strategy at Harappa. You have the summer monsoons, and then you have the northwest winter rains, and two types of cropping are taking place. One cropping system is dependent on these drier foods like millet, rice, beans, and grams, and the other is winter wheat, barley, peas, lentils, and chickpea. Now, throughout the occupation at Harappa, farmers constantly use, none of these crops disappear, but they appear to have been very cognizant of the ecology of the weather systems. And so they used barley at one time, they switched to wheat. They were constantly switching their cropping patterns, but always using all of these things. Very end, the rice actually appears quite early, but the rice becomes more of a factor later on. Okay, I'm just going to go on this because I see it talk too long. These are just the general cropping trends at Harappa. And the thing about this chart that's really interesting right here is this. Now, somebody who isn't aware of the Indus civilization could say, oh, this is really good evidence that they totally changed their cropping pattern. They begin to use, we see a lot of weeds and chaffs. The significance of that histogram is that at the end of, in the later parts, in the late Harappan, well, first of all, Harappa doesn't end at 2200 or 2000 BC. I know the highest date we have is 1700, but sometimes you'll see the date of 1300. What happens is they change their, the way in which they harvest and grow things. This chart shows that they were no longer processing the grain out in the field, they were bringing it into the household. And this suggests that you have a shift, which could be economic, could be political, it could be a breakdown of a variety of sorts. But it's really important, and it's not something that these geologists wanted to talk about. Okay, these are just more. I won't do that so much. This is very nice. This is from Karsten and Salata, who did some phytoliths. And if you look at the last chart, which is in the period just before, just around this time when all this is supposed to be happening, you'll see that the importance of summer millets is low, which would be sort of backwards. Okay, so, somehow that got cut off. I said that a macroscopic view of the Indus that is not historically based on change is really quite useless. It's the beginning of a project somewhere, but it's not an answer to anybody's question. It just means that they made a determination based on their data. This interpretation based on this imaging provides us snapshots, totally disregards history. In fact, in an interview of the lead author, he said, disregarding history, that the Indus civilization was a Goldilocks civilization, by which he meant that it was in this region briefly, only because of these specific conditions of the stability, etc. So he really missed an understanding of human reactions to change and regional variability, and we should really be a part of this conversation and not just an addendum in some appendix of a thing like this. So I think what we need are future projects where we incorporate our research goals and also the research goals of others, like a climatologist or a geologist, in what Vanderloo calls transdisciplinary teams. This is what we actually need.